Hello students, in the last video lecture we have discussed the introductions of volumetric analysis, and in that case we have make a statement like that this volumetric analysis is the type of quantitative analysis. In this type of analysis we are measuring the volume of the solutions. We can say aqueous solution, volume of the aqueous solutions we can measure in the volumetric analysis, and which type of glasswares are used in volumetric analysis. We have already covered all the glasswares related which are required for the volumetric analysis. And after that, at the end of lectures, I have left one questions to you, that is a what is a primary standard. This question is I have asked to you, and said to you that find out the question answer of these questions. I hope you have been try to find out the questions answer of these questions. So if you are not able to find out the answer of these questions, I will tell you the answer of these questions in today's video lecture. Okay, so the question is what is a primary standard substance, and definitions is in front of you. The substances, primary substances are that are so pure, that means the primary substances are in exist in a pure form. We can say the substances that are so pure that the amount of substance in millimole in moles can be calculated accurately from their mass are called primary standards. Number of calculations which are required for the volumetric analysis. So the calculations we can calculate accurately from their mass, that's substances we can say these are the primary substance. And second thing is that primary substances are exist in a pure form. So these are the two basic requirement of primary substances, and on that basis I have made the definitions of primary standard substances. And the definition is like that: substances that are so pure that in amount of substance in mole and can be calculated accurately from their mass are called primary substances. So this is the definitions of primary standard substances. Now we will shift to what is the primary standards substances requirement, which kind of requirement, how we can say these are the primary substances or these are the secondary substances. Okay, so what is the requirement of primary standard substances? The first requirement is that the primary substances should be available readily, that primary substances of chemicals, or we can say these should be readily available in market or in laboratory. This should be readily available. Then that substances we can say these are the primary substances. Next thing is that this primary standards should be available in pure form. This is already we have said in the definitions of primary standard. These primary standard substances may be or should be available in pure form, readily available but available in a pure form. This is the second requirement of primary substance or primary standards. Next thing is that not readily react with atmosphere. Most of chemicals readily react with atmosphere or water or some readily catch fire with when it can come in contact with atmosphere. Such type of substances we cannot say these are the primary substances. So primary primary substances should be should not readily react with atmosphere. This is the next thing. This is the next thing required for the primary standard substances, or that substances we can say these are the primary standard substances. Now next thing is that a primary standard should be easily stored. This is also very important requirement or very important features related to primary standard substances. Readily available, exist in pure form, and should not react with a atmosphere, and this primary standard substance we have to store in laboratory. So storage may be easy in point. Okay, so this is the requirement of primary standards. You have to store it. So storage should be easily, or we can store it in laboratory easy way. Okay, so this is the next requirement of primary standard substances. Now the next is have a high molar mass. The primary substances which we have to use in volumetric analysis, that substances should have a higher molar mass. That substances have a high molar mass. Okay, so in the primary standard substances should be inexpensive. We have to easily available in pure form, should not react with atmosphere, easily stored, high molar mass. But we have to think about the expenses, we have to think about the cost of this price, that substances. So these primary standard substances should be inexpensive. That means we have to easily buy that type of standard substances, and easy to use, easy to available, easy to store, and with having higher molar mass. These are the requirement of primary standard substances. Okay, the example of these primary standard substances are sodium carbonate, sodium borate, hydrated oxalic acid. These substances we can use as a primary standard substance to make a standard solutions or in volumetric analysis. Okay, so this is the best example of primary standard substances. And most of time, the questions may be asked in your exam like that: what are the primary what are the primary standard substances, and what are the requirement of the primary standard substances? This type of questions may be asked in your exam, so you have to be ready for that. The definitions of standard substances, you have to write in your notebook, and you have to write all the requirement of primary standard substances. That means the readily available in pure form, should not react with atmosphere, we can easily stored in laboratory. That's primary standard substances have a high molar mass, and according as per you have to buy the standard substances, and at that time you have to think about the expenses. That means the cost of the that primary standards. So this primary standard should be inexpensive. That means cost is not much more to as compared to other chemicals. So best example of this primary standard substances is the sodium carbonate is the best example, the sodium borate is best example, hydrated oxalic acid is also we can use as a primary standard in volumetric analysis. Okay, so this is the basic requirement of primary standards and definitions of the primary standard substances. Okay, so making a standard solutions, what is the exact process? Because we have to make a standard solutions when we are performing the volumetric analysis. And for making a standard solutions, what you have to think about, or which kind of precautions you have to take when you are making the standard solutions. So we can say the standard solutions can be prepared from a primary standards. As I have said that the primary standards requirement I have already covered in the last slide. So we have to make a standard solution from a primary standard substances by dissolving an accurately known mass to make a up an accurately known volume of a solutions. This is the standard solutions. We can say the standard solutions can be prepared from a primary standard substances by dissolving a known mass to known volume of a solutions. That means the weight of solutes we have to known, and weight of solution, or we can say volume of the solutions we have to known. All these things you have to known to making a standard solutions. Then the precise volume of solutions can be obtained using a volumetric class. The precise volume, that means the accurate volume of solutions, can be obtained by using a volumetric class. First of all, you have to take a weight of that volumetric class. Place weight sample in the volumetric class. After that, half fill with water, shake to dissolve the sample, and after that, add water to calibration line and shake again. This is the standard process to make a standard solution. First of all, you have to select the primary standard substance. After selecting, you have to weight that primary standards, and after weighting, you have to place the weighted sample in the volumetric class. That weighted primary standard in the volumetric class, and after placing, you have to fill with water. Half quantity of water you have to add in the volumetric class, and you have to dissolve it. To dissolve the sample, you have to shake that dissolve you have to shake the to dissolve the sample molecule, that is primary standard substance, and after dissolving, you have to add more water in the volumetric class up to the calibrations line. One calibration line is each on the glass of the volumetric class, or neck on the volumetric class. So you have to add more water up to the calibration line and shake again. This is the standard process to make a standard solutions in while you are performing the volumetric analysis. So this is the standard process. Okay, so this is the primary standards process. First of all, I have mentioned here the uh, place of weight sample. This is the primary standard substance I have pour in the volumetric class, and after that I have to add half quantity of the half fill with water. This volumetric class I have to fill with half quantity. So this is the water level, and sample molecule is dissolved. When I shake this volumetric class, then this chemicals, these primary standards can be easily dissolved. After dissolving, I have to add water from up to this point, because this is the calibration marks. Up to the every volumetric class has this calibrations lying up to at the neck of the volumetric class. So this is the standard process to make a standard solutions. So this is the preparations method of standard solutions. When we are performing the volumetric analysis in laboratory, at that time I will tell you how to make a standard solutions, and how to utilize, or how to identify which is the standard substance or which are not a standard substance. So first question is that why do you not use common acidic and basic standard as a standard solution? That means the HCl is there, KOH. HCl means hydrochloric acid is there. Suppose potassium hydroxide is there. So why we are not use this type of compound or this type of substances as a primary standard? So the answer is that because KOH, that means the potassium hydroxide, sodium hydroxide, hydrochloric acid, and H2SO4, that means the sulfuric acid, are either impure. These compounds are exist, or maybe exist in impure form, or their exact concentrations may not be specified. The concentrations of that type of solutions, that means the KOH solutions, NaOH solutions, we cannot specified, or exact concentrations may not be specified, and the bases tends to absorb water as they react with carbon dioxide in the air. So the base, that means the KOH and NaOH, they absorb the water as they react and with carbon dioxide. That means these bases are react with water molecules. These bases can react with the atmosphere and get impure. They get absorb the water molecules and get in impure form. So this type of KOH, NOH, HCl, H2SO4, that means the common acidic and basic standard substances we cannot use as a primary standard, so to make a standard solutions, or we can say this KOH, NOH, HCl, or H2SO4 are not used as a primary standard substances. So you have to use salt. Salts means, that means carbon dioxide, sodium carbonate, oxalic acid, all that, all this type of substances you can use as a primary standard substances. Okay, so this is the exact method, and the question, this type of questions arise in your mind, then the answer of this question is like that, because KOH, NaOH, HCl and H2SO4 are either impure form or their exact concentrations may not be specified. The basis tends to absorb water, because in the requirement of primary standard substance we have already mentioned that your primary standard substance must be in pure form, and you have to calculate exact molar mass of that substances, and these primary standard substances cannot react with atmosphere. Such this type of requirement we have already, in the last slide we have already covered all these things, all the requirement of primary standard substances. But this KOH, NOH, HCl and H2SO4 are not follow this type of requirement. That's why we are not use this type of chemicals as a primary standard substances, or to make a primary standard solutions. Okay, so what are the actual setup of this volumetric analysis? First of all, you have to uh, clamp the burette. You have to attach to a clamp stand above the conical glass. You have to first off, what is the actual setup of volumetric analysis? This is the questions. So this is the questions, or this is the how to perform the volumetric analysis in the laboratory. So this is the important thing when you are performing the when you are discussing the volumetric analysis. So first thing, you have to uh, clamp the burette in on the stand above the conical glass. Clamp this burette, you have to clamp this is the burette. So this is the burette. This burette you have to clamp on the stand up to the, or above the this conical glass, above the conical glass. Now next, the burette is filled with one of the solution. In case of yellow standard solution, suppose you have to you make the, you have prepared the standard solutions, then the standard solutions you have to pour into this burette already stand, already clamp on the stand above the conical glass. This is the actual process. After this clamping of this burette, you have to add this standard solutions into the burette. Okay, now a pipette is used to measure an aliquot of the other solution. In case of purple solutions of unknown concentration into conical glass, this is the known concentration solution, this is the non concentration solution. That's why I have said that the standard solutions always you have to pour in the burette, always pour in the burette. So this is the standard solution, and the standard solutions definitions tells us the standard solutions has known concentrations to us. If you are an analyst, you have to analyze the you have to analyze the volume of the solution, one volume of the unknown concentration. So this is the unknown concentration, this is the this is the standard solution, this standard solution concentrations known to us. That's why we are this is the known, this that's why we can say this is this known solution, this is the unknown, so this is the unknown solution. So first of all, I have poured the standard solution in the burette. After pouring this, I wanted to titrate this standard solution in standard known concentrations to unknown concentrations. So first, after that, you have to pipette out these unknown concentration solutions into conical glass. So okay, so and prepare a number of flasks for a repeat test. You have to perform the exact and precise volumetric analysis result. You have to make a number of flasks for a repeat test. First test, second test, third test, fourth test. After fourth and fifth test, you will get the accurate, that means the accurate and precise result of your volumetric analysis. This is the actual process of volumetric analysis. Okay, so this you have to remember all these things, what to do in the laboratory while performing the volumetric analysis. This is the most important thing. And at the last, when you are pipette out the unknown concentration solution into the conical flask, you have to add a suitable indicator to titrations. So last indicator is added to the conical flask. Most of students indicator is added to the standard solutions or added to this burette. So remember one thing, after pipette out of this unknown concentration solutions into conical flask, after pipette out, you have to add 2 to 3 drops indicator in the conical flask, not in the burette, not in the stock solutions. This we can say this is the stock solution, this we can say this is the sample solutions. You have to add into this conical flask 1 or 2 drops indicator solutions. Okay, so this is the exact setup or exact process of this volumetric analysis which you have to perform in the laboratory. So first of all, process titration, we can say this is the titrations. Read the initial level of liquid in the burette. You have to read the initial level, that means the zero level of this burette. After that, turn the tap to start pouring out liquid in the burette, to up the burette into the flask, and swirl the flask continuously when the indicator begin to change color to show the flow. Okay, after that you have to read the initial level. After that, you have to pour this burette solution, that is known concentration solution, into unknown concentration solutions, and continuously you have to shake that volumetric flask, or shake that conical flask continuously. And after, when the indicator begins to change color to show, then the flow, the it one time, after suppose a 5 ml 10 ml adding, you will get the uh, different color solutions rather than this pink color solution. So we can say your reactions or your volumetric titrations is completed here, and you have to note down the reading. Okay, just like I have said, that when the color change permanently, that means this color is pink color is here. When the pink color change to orange color, that means they permanently change. Then they stop the flow and read the final volume. That means we have initially we have read the volume of the burette, that is the initial level of the burette, that is 0 ml. And after adding 5 ml, something like that, 5 ml, this color will get changed and into orange. And up at that point, I have to read the what final volume, and the volume change need to be calculated and written down, and this volume is called as a titer. This volume is called as a titer. So this is the exact process of volumetric analysis. Okay, and the after note down after note down this titer reading, that means the after note down this burette reading at the color change, at the color, that means the pink to purple color. This is your end point of your titration. So at the end of your titrations, you have to note down the this type of note down the reading of the burette. And after that, you have to repeat the same titrations into next conical flask, or you have to use you have to repeat the process until you get a precise result of your volumetric analysis. So you have to repeat this type of process again and again, 2 or 3 times, you will get the precise result of your volumetric analysis. So this is the your actual process of the volumetric analysis. I hope all of you must have understand all these things which I have covered in the today's video lectures. If you have any query related to the what is the process, and how to identify, or how to add which indicators are suitable for this type of titrations, you can contact me. Or what is the meaning of titrations and all these things, which I have covered in today's lectures. If you have any query related to the volumetric analysis, you can contact me. Okay, thank you very much.